Hello guys, welcome to the tutorial of object-oriented programming in Python. There are 5 sections for this video and it started from the beginner-friendly concept to the intermediate and more advanced concept. For each section I put the timestamp, so if you want to go into the more advanced concept or start with a beginner, feel free to do whatever is suitable for you. Good luck! Hello guys, welcome to the first video of object-oriented programming in Python, where we try to learn the basic concept and fundamental of the Python classes and at the same time build a chatbot in order to understand the concept better. In this video especially, we'll cover the absolute essential of Python classes, what they are, why do we need them, and how to build your first Python class. Let's start. We will start to create our first Python class with creating a new project. We can create our first file, we can name it as main.py. We can go, for example, for the documents and create a new folder. We can set that OOP1. We go into it and we create our file. So the next step is that we want to define class. In programming, the class is like a blueprint, and the object is something that you build based on that specific blueprint. Think of a class as a recipe, and objects as a cake that you bake based on that specific recipe. The recipe defines the ingredients, the steps that are needed in order to create that cake, but each cake that you bake is a separate object that can have its own decorations, flavors, and personalities. Let's define our class chatbot, basically the blueprint that we want to define, and the object out of it will be something like friendly chatbot, sarcastic chatbot, or whatever that we want to create an object from this blueprint. The class, you can write it like this in Python. We define this and let's keep it simple. We can keep it like that. We just, whatever it is, it's just pass. So the pass here means that whatever happens here, it will continue without raising an error or returning something. And at the end, pass is just a placeholder. But how can we define, for example, object out of it? We call the first object, for example, here, bot1. If we want to have bot1 out of the blueprint of the chatbot, we can easily set that chatbot. Oh, sorry, there's a typo here. Yeah, with empty parentheses. And with that, we have our object bot1. And we want to see what is inside bot1. Let's see together. We have bot1, we save it, and we run it debugging with the Python debugger and the currently active Python file. Okay, you see the output here. There's an object on this specific address. So we know that our object lives there, and we create the object out of this blueprint. And this object itself is a live entity, or whatever you want to call it. It's basically, it has its own personality now, which is an instance from the chatbot class. Okay, now we want to add a name for each class. Let's say that we want to say each chatbot, it has its own name. In that case, we can call something like init. The init function is called automatically whenever you create a class. So whatever that you want to initialize the class, you can add those variables to the init function. First, we need to define is as a function. Init is a function, so for the method inside the blueprint, we need to add def. We add 2 parameters for it, self and name. The self is referring to the current object that we are creating now, and the name is the name of the chatbot that we want our instance to initialize it at first. We said that the self name should be equal to the name. So in that sense, if we want to define 2 bots, for example, the first bot, we said that Aiden, and the second bot, we can copy paste first. We can name it as Laura. And if, for example, here we want to create the name from bot1 and bot2, let's put it in 2 different prints. you can see it's Aiden and Zoro. And these two objects, there are two different objects. If you want to check where the addresses from those objects, you can put bot1 and bot2. And you can find the address of those instances that are being created based on the blueprint. Now let's give our chat some abilities or the actions that it can perform. In Python, these are just methods, which are basically functions inside the class. Like what we said for the initialize, we can define our own method inside the class by the name that we want. I will continue to write the attributes, then we can talk each other after I finish writing. Now we wrote two methods here. The first method is greet. The greet is basically introducing itself, that what is the name of the chatbot. Here you can see the new way to add your self name into the message that you want to print. You can see when you add f here for your string, inside that string you can put the variables that you want that string to be hold of. The another method is respond to greet. We put three default messages that we want our chatbot to respond to. Hi, hello, and hey. Whatever the user input is search into the greetings that if it's already included in that. In case that it is, then we send a response to it. And in case that it's not, our chatbot said that not sure how to respond to it. Let's say our bot1, it has the greet. It calls the function first, so it introduces itself. Then bot2 introduces also itself in order to check if they're functioning correctly. And if we delete those and run it, we can see that the first one said that hello, my name is Aiden, and the second one tells that hello, my name is Zoro. We can make sure that they're totally separate from each other, and the values that we initialize in those methods, they're working properly. Okay, let's use also the other function that we define for each of those bots in order to see how it can respond to whatever user inputs that is there. We said that it's, for example, for bot 1, the Aiden one, what we can say is only hi. For the second one, I want to use different thing, for example, what's up with question mark. Let's see how each of those will respond to it. Okay, perfect. The first one introduced itself. The second one also introduced itself. The first one answers me back, nice to meet you. But the second one said that I'm not sure how to respond to that, as we expected from our recipes inside the class. Today we will make our chatbot more secure and more powerful by learning encapsulations and inheritance in Python classes. By the end of this video, we'll learn what encapsulation is, how we can use the inheritance to create a private memory and different personality for our own chatbot. Let's start. In Python, the encapsulation is controlling the access to the data. Think of it like backpack. Some items are public, which means that anyone can see them. Some of them are protected, which means that your close friends, they can ask to borrow those items from you. And some of them are private. It means that only you can see them. In our code, we can define it like that. The self name here is public. The next one, in that case, it's a mood of your chatbot, is protected. It means that that can be accessed within the class or within the subclasses. We indicate it in Python by using single underscore for your variable. The next one is memory. Memory is private and you don't want anybody to tamper with it and to access it outside the method that you want to change and access this variable. We will show it by double underscore, and Python will mangle the name by making it harder to access from outside the class. Okay, how can we modify it inside the class? For example, we define a method like this. We define the remember method. So basically the remember method is just taking any message that your chatbot will receive from the user and append it into the memory. So as you can see, this is only the input to your memory, which you can tamper it inside the class, of course, but there is no get function for the private variable, since the private variable by definition shouldn't be accessed outside. Another method is recall the memory. So whenever you want to access your memory inside your chatbot and you want to train your chatbot based on the previous memory or any other purpose that you want, you can access this memory by calling this recall memory method. That's defined here, really easily done, and that's about it basically. But why hiding the data matters inside your Python code? For example, if your chatbot stores sensitive data that you don't want to show other users, or we don't want any outside code to be accidentally messed with it, then hiding its data is really important. By keeping the memory private, we ensure that only within the class that variable can be modified and can be accessed. So how can we check that? We have defined from the previous video these both chatbots. So let's say that we want to work with Aiden 1. Here we say that bot 1, he needs to remember user said hello. And we print what has been recalled from this memory. So basically it's just bot 1, it recall memory as a function. Let's see what it will show us. Okay, as you can see, the method returns the memory that we want, as we define inside the class to be accessed to our private data. Just note that we don't change the data, but basically we define an interface in order to access that memory. But what will happen if we access directly the variable? Would be that the same, that we just print the memory without calling the interface to access it from the method, for example? In that case, we can test it. The best way is to test what will happen if we do that. So the memory is private and we want to see what will happen. Let's see. Okay, you can see the error here. Here it says that the chatbot object has no attribute $_ But what we can see here, we see this variable. So in the case of the Python, understands that, okay, this variable is private and it shouldn't be accessed outside of the class. Let's say that we want to handle the memory inside the class now. We know that we cannot handle it outside unless we define the interface like the method that we defined. But how do we want to do that? Let's make our chatbot's memory as a part of the conversation flow that we have with the chatbot. We have already the greet defined based on the previous video. Let's define additional method for it. We define the respond. So we define the method like that. The flow is the same as respond to greeting. The only difference is that now, based on the user input, we append it to the memory. If it's greetings, we respond to the user back. But if it's not, we tell the user, tell me more. I use here self-memory append user input. But here we define remember method inside the class. Let's use that. Let's not make everything like a copy paste in the code. So if we want to use that, we call the recall memory. And we put it like that. Now we use the method properly. So let's see how it will behave. We delete all the previous prints that we wrote. We say that respond to hello. We want to greet chatbot. And we want to tell something else. For example, I love pizza. If you love pizza as well, tell me in the comments. Then for the bot one, we said that recall the memory. We want to check what kind of data is already inside our memory to double check if everything works as we expect. We save it, we run it. Okay, we got the error. Now I understood, I hear what you have been shouted to me. You already mentioned that hey, it's not the right method that you use here, and I just used the wrong method. So you will get this error that it got one positional argument, but two were given. And one nice thing happens here is that you have already give one input to it. Why it tells two were given? The reason is that the self is already being given to this method, because the self has been defined as a inside the class method. So if you put the second argument here, which in your eye is just one, by default it assumes that you give two arguments. Let's correct this one. It's just a simple bug in our code, resulted by me, of course, and restart everything. We have already nice to meet you one when we say hello to the chatbot. Then when I say I love pizza, it tells me and responds me back. And at the end, when I recall all the memory inside this chatbot, I see that I send hello and I love pizza to the chatbot. Perfect, we already saved all the memory that we want our chatbot to have. But what about different personalities? We want to basically have different kind of chatbots and different kind of personalities, as we talk about. In the previous video, we learned to have different names. But what about different memories or different subclasses based on this class? This concept is basically inheritance. Inheritance lets us create the new class based on existing class and using code while adding unique behavior. We can say that this is our base class. I delete the mood here. Let's not talk about this protect method. I will delete the comments here. And that's our base class. Now we want to create two new chatbots. One is friendly, one is sarcastic. And we want each chatbot to respond differently when we put any message inside those chatbots. But both of them needs to be created based on this base class. Now we basically define a new class. We say that friendly chatbot needs to be based on the chatbot. And we define it like that. The next one is sarcastic chatbot. And the same base will be used for this sarcastic chatbot. What is the difference between these two? We want everything the same based on this base class, but only the response is different. Let's delete the response to greeting to make everything simpler. We just keep the response. And as you can see, I have a problem with the name of the response here, and I corrected it. Anyway, the response here is different. Try to type response. The IDE will recognize it that we want to create the response based on a base class. If we try to make it by default, it tries to call super. Super response is basically calling the response inside the parent, which is the base class, which is the chatbot here. But we don't want to retain just what has been default in the base. But let's make something interesting. We say that the base response is like that. So we have the super, but what we want to return at the end is different. We want the response from the base class, from the parent, plus the response that we want our new class to have. Let's keep it simple just to say I'm so happy we are talking. For our sarcastic chatbot, we don't want to use the same. I just copy pasted the friendly chatbot inside of it, but let's change it in a totally different way. In friendly chatbot, we use the base response from the parent. Basically, if it gets greeting from the user, it will be answered like that. For our sarcastic chatbot, we want something different. Let's change the method in a way that we want to define. We say that if user use greeting, we answer something like this. Let's say that instead of the original greeting, it answers us, oh wow, another greeting, so original. Or for other messages, it answers like that. Let's test those two chatbots to see what they will respond to us. The important note here is if you look inside friendly chatbot and sarcastic chatbot, there's a difference between these two when they approach the problem. Friendly chatbot uses super response to call the parent version of the class and then add extra flair into it. But in sarcastic chatbot, it completely overrides the response method. So whenever you want to build on top of existing method, super function is your friend and it helps you to not replace the whole method in your new class. But if you want to replace everything in that method, of course you're free to do it. Now let's see what those two bots will respond to us. I will chat bot 1 to the friendly chatbot, Aiden is friendly chatbot, and for example, Zara is sarcastic one. We use the same example as we did for the previous example, but the difference is now we use this inheritance inside of those. Let's see what they will respond and what they will do. Okay, the first one answers us back, nice to meet you, I'm so happy we are talking. So as you can see, when we use super method here, we already got the base response that we wanted from the parent class without overriding everything. But for the second one, if we see here, oh wow, another greeting so original, we don't see anything from the base class into it because we already override everything in it. If you look closely into the response that we got, in the friendly chatbot, when we recall the memory, we see that the memory is already been there. But for the second chatbot, we don't see anything. You can pause the video just for yourself to think about why this happens. Although both classes, they have the same parent. The answer is simple. We override everything inside the response. And if we look inside the parent class or base class, we see that this remember function is called here. So inside friendly chatbot, when we use super method, we already called this remember in order to save the user input into it. But for sarcastic chatbot, we already override everything. So if we want to have this memory be saved, we need to do it again here. Now it's your turn. We can create wish chatbot just to train your knowledge about the inheritance and encapsulation in general in this session. Now you know how you can protect your data by using the encapsulation. Also, you learn how to use inheritance in order to create different personalities for your chatbot. We talk about polymorphism, one of the most important ideas in object-oriented programming. Polymorphism will allow our chatbot to have the same interface, but they can act totally different from each other using the share interface that we have inside our class. The word polymorphism comes from the Greek. Poly means many and morph means form. In programming, it means the same function and method name can work in many different ways depending on the object that it calls it. For example, the plus sign operator. It can add two numbers or it can concatenate two strings. Same interface, two different behaviors. In our famous chatbot project, we want to use this concept. Therefore, all the chatbots have respond method, but each type of bot responds differently from other ones. It's kind of the same example that we had in the inheritance in the previous video. Polymorphism in Python is often achieved through method overriding. That means the subclass defines the method the same name as the parent, but changes its behavior. If you want to expand our chatbot, it's kind of like this. So we keep the remember part here. We say it's greetings and so on and so forth. Let's delete this part and change it in different way. Let's say that the base class has this return function. It remembers the user input and returns that this name or this chatbot name heard what the user has as an input. Now we use the method respond here from the parent class inside the friendly chatbot and sarcastic chatbot, but with the concept of polymorphism. In that sense, we use the method name as an interface for both bots. The behavior, however, is like this. The difference between these two methods is the behavior of the response that we want to have for each chatbot. Here, the respond method will give the user back based on the friendly chatbot personality, and here is different personality as a sarcastic chatbot. Let's test them. Let's define bot 0. Bot 0 is a parent. We want to check how the parent will behave. I name it parent to just keep it simple. Let's say we delete everything here and we copy paste these three print functions. We say hello there in order to make sure that it's different than greet, but let's see what they will answer. Parent says, I heard you say hello there. Aiden says, that's wonderful, hello there, mad my day. Okay, there's a our friendly chatbot is mad as well. Let's run it again. So that's wonderful. That's made my day already. Hello there. How exciting. as Zara said, as a sarcastic chatbot. As you can see, we use the same interface, but acted differently upon each interface that we created. Here is where polymorphism shines. You can treat all of these bots the same, even though they behave differently. We'll put them in the same list and call the same method on each of them. Let's say that we have the list of bots. We copy paste everything that we have here. Okay. Here's the fun part. Let's say that we want to just define a for loop in order to go through all the bots that's defined in our list. We are treating all these bots, as I said before, the same. But polymorphism allows us to get different personalities from each bot. Although from the for loop point of view, we are calling the same method for each of them. And as you can see, we get totally different response based on the respond function that we define inside each class. That's polymorphism in action. Now imagine you're chatting with the chatbot, but you want to change the personalities on the fly. Because all the bots share the same respond function, we can swap them in and out easily. Let's make a quick magic here. We define a function called chatWidth. And this function gives us the answer of the bots that we already talked with. Let's say there's a current bot like this friendly chatbot that we have from here. On the runtime, we want to switch the personality. So we can define it like this. Let's see how it will behave, because basically we use the same method for each bot, but we use different bots with different personalities. If you can use the object-oriented programming in the right way by using this polymorphism, you can unlock a lot of features and you will have a magic power inside your code. Now it's your turn. Create a new chatbot class named, for example, excited chatbot that repeats all the user's input, all caps, with lots of excitement in the answer. Then put it in the list of the bot and see how that will respond when you go through all your bots. Great work! You mastered polymorphism and method overriding. Now you can define one interface with many behaviors. Your code will have clean and flexible design. And in your chatbot, you can easily swap the personalities. Today we will talk about 3 different methods in Python classes: the class methods, static methods, and Python-specific Dunder methods. In Python, not all classes belong to one object. We have 2 special kinds of methods in addition to the normal instant methods. Class methods belong to the class itself, not any single object. Static methods are utility functions inside the class that do not depend on the instance or the class. Okay, let's define the class from scratch again. So the code, this code belongs to the previous tutorials. Let's create a new file that we said that this is OP session 4, of course, and let's define the class again. So we define a class chatbot, just copy paste the name, and we define a variable called bot count. The bot count basically is the class attribute. Let's define the initialization method, and here in the initialization we add the bot count be actually +1 whenever we create new object out of this class. Okay, to define the class method, we use something like this. So @ class method, then Python understands that this method is class method, not the normal method that we defined before. The class method is basically how many bots that we have. As you can see, we define this attribute bot count inside the class, but instead of using self here, we use CLS. CLS is basically the class methods that we define here. From Python point of view, it accesses the class itself, and whenever you call the attribute variable that you define inside the class, the attribute variable will be called from the class. In this method, we want to get the return on how many objects have been defined from this class. The static method looks like the class method, but you use @ static method. In this case, we define something like this greeting. And here as well, we only need to add the input variable, not self. And we want to return the message So if you want to run and check how those kind of methods are working, let's define bot1 and bot2 with the chatbot. The bot font, we keep the same of Aiden, and bot2 is Zara. Then we print the chatbot. How many bots do we have? It returns us the static method true and false. In case that message is hi, hello, and hey, it returns true. In case it's not, it returns false. Let's run it to see what will happen. As you can see from the output, there are currently 2 chatbots have been created from the chatbot class. And this is returned by our class method. As you can see from the how many bots, the CLS variable correctly called the class and correctly called the bot count from the attribute of the class. A static method, however, it doesn't need CLS or self at all. It is just the helper inside this class. A common use for class methods is building factory methods, which is alternate ways to create an object. Just as an example, let's see in this way. Let's define a class method that we want it to act as a way to create instance if we call it directly when we want to create, for example, the new bot called Nova. Let's define it like this. For example, this is the method with the CLS, of course, and you want to get this data. Data in that sense, we have only bot name, so the name would be the data that we want to give. But let's keep it general and we return the CLS and data. So let's write it here. We call it bot3 and chatbot on a string. And let's call it Nova. And if you print the bot3 name, let's run this. So in that case, we need to get the Nova that's expectation. Let's see if we get the same variable. As you can see, bot3 returns Nova. One question is that what will happen if we add the previous class method, which basically points out to how many bots do we have after bot3. If I want to confirm is if there are 3 bots have been created or 2 bots, we can check it like that. Let's see it again. Nice. As you can see, there are 3 bots now. So this is the new way to create this instance by calling this class method directly. This is useful when you are creating the bots from external resources like files, configs, APIs, so on and so forth. Python has many special methods that start and end with double underscore. For example, you already saw initialization, but there are also other methods, which are often called Dunder methods. They let us control how objects behave with built-in functions like print, equal, or any other functions that you use in Python. Let's define some of these Dunder methods inside our chatbot class to see how they are working. Let's add it after our static method. We define the first one from str. What it will return, however, is different. It will return the chatbot name. The another method that we want to define is representation. So what we say is that the representation basically shows the object that we have. And last but not least, we define the equality. So we define other instead of variable. It basically returns if other is instance of chatbot class or not. But we want to also, we can also define like if the chatbot name of the other also equal to this specific class that you have, the self name. Let's use our already defined 3 chatbots that we had. We delete all the print functions. Here we put the bot1 inside the print function, and print function accepts a string. But in the Dunder method of the class, we already define whenever we want our class to be behaved or to be handled like a string, what kind of data it needs to return. So the expectation here is it returns chatbot name is self name. But let's see if in practices, you can see chatbot name is Ada. So it behaves exactly that we define inside our class. Let's check the another one for bot1. This is the representation Dunder method, or the magic method that you can use it to represent the class itself. We have to see something like this, but we'll see how it works. Yes. So the representation, since we already put it in an array, it shows that this is an object with the Aiden as we created here to be represented like that. Okay, the another is equality. So equality, we said that bot1 if it's equal to bot2. When we add this equality, this Dunder method will be called. And as they expect, it returns false. Let's test additional thing here. We want to check if bot1 is equal bot3. In the case of Big Nova, they're not the same, of course, but let's change this one to Aiden and see what will happen. As you can see, it returns true. It basically validates 2 points here. The first one, of course, is the Dunder method that's working both in the case of unequal classes and equal classes. And the another one is that we define this class method, which also create the object in different way. And here we prove that even when we use the class method, it shows that this class method create an object in the same way that we create here. There's no difference between them, only the way that you create it inside your code. With Dunder method, we can also overload operators. For example, what if we want to add two bots together to join forces? Let's see how that can be implemented. We can implement it as additional. So we want to add the other class to the self class. In that sense, we say that self name. As you can see, this other name is white here. Now let's delete these ones and we want to print something like this. The bot team is bot1 plus bot2. And we want to print, of course, bot team. Now we are dealing with two Dunder methods that we define. The first one is this add, which we use it here. And the second one is this string, which returns the name of the chat. Okay, the chatbot name is now Aiden Zara. So we redefine this plus operator sign inside our own class by our own definition. And we basically overload the operator here. In this example, of course, we use the simple use cases in order to show how this works, but for more complex setups, you can use them in any way that you want for your object and for your classes to be handled by your code. Now it's a time for your challenge. For example, add the Dunder method of length to your chatbot, and it returns, for example, how many characters does your chatbot have. And also add a GT Dunder method or grade, in which you can compare two chatbots' name and to show which one has longer name. In this video, we will go beyond simple inheritance and simple concept and try to design a modular system using composition. By the end, our chatbot will be broken into different components: memory, natural language processing engine, and response engine, which makes it easier to extend and it make it scalable. So far, we've used inheritance to create different personalities for our chatbot. That works well when the variation of things are basically in the same type. But sometimes you want to build object using smaller pieces and smaller components, like building blocks, rather than just extending a parent. That's composition. So if I want to give you an example in the real world, a sport car is the inheritance of the car as a parent. But if we are talking about the composition in the car concept, engine, tires, seats, they're all part of the components which you need to combine together to create a car. For our chatbot examples, inheritance works for the sarcastic and friendly chatbot, for the personalities that we define. Composition, however, works for features like memory, natural language processing part, or even the response part. Let's start breaking our chatbot into the pieces that we can use. From the previous examples from the chatbot, we have this class of the chatbot. The main class includes all the parts that we want to separate. Let's start with the memory. We have the remember and recall memory. In order to do this, we define the class memory. And in the init function, we use something like this. So the name part, of course, will be not part of the memory since it's only the component of the memory, but the memory part will be, of course, the variable that you want our memory to have. So in order to extend this class, we need to move also these two parts to our components memory. So now the remember and recall parts are part of the class of the memory. We can also delete this part from chatbot in order to make it totally separate. The next part that we want to define is NLP engine. For that, we also define a class. For the first method, we define a static method. And the static method, as we had from the previous video, I can actually copy paste it from here, is the greeting part. Another static method that we want to add to this class is tokenizer. So tokenizer get the message, make it a lowercase and split the message into the tokens. You don't need to know what tokenizer is or what it does. The only thing here for you, the important part, is it will get the message and make each word separate. That's the only thing that you need to know. The next class is the response class. Of course, we want our chatbot to respond to a user. So we call it like that response engine. It generates response, it gets message, and also it gets the NLP engine. The NLP engine here, the type is, of course, our class that we define here. You can also add the type here. For this series, I didn't use types because we wanted to focus only on the object-oriented programming. But in case that you want to add a type, you can easily add it like that. Then at least you make sure that this input is related to NLP engine. This avoids any unwanted input to be added here, but this is basically optional. It makes your code much more readable and also easier for people to use your API or your code whenever they want to modify it or if they want to use it as an API. Anyway, let's define our generate response. So the generate response here has a condition. If the NLP engine recognizes that the message is greeting, it will respond like the greeting. We have also here defined a response. Response is a hi there, nice to meet you. And in case there is no greeting, we just return what user said. We say you said the message that user inputs. Now we have three components which we separated from each other, and by combining those we want to create our chatbot. Let's see how we can do that. So the chatbot now consists of three elements, these three components that we want to add to the chatbot. So the first one is the memory. The memory, we can give it easily as an input. The second one is NLP engine. I will add the type of each input in order to make it easier for you to understand where those inputs are coming from. I would add a type for each input in order to make the code a bit more readable, especially in the case that we define our own components, which we will give as an input to the chatbot. Okay, like the name, we want each of these chatbot objects have their own. Like the name, we want each of the chatbot objects that we create from the chatbot parent has their own memory, NLP engine response. We can add it like the name that we add on the above. We can also rename this response to response engine to have the same shape as the class's name. Okay, this is the initialization part. We want to now change the chatbot, how we chat with this chatbot. Let's define that method as well. What we want to do at first is to remember the message that our chatbot get as an input from the user. So we easily use the memory object, and from the memory, the remember part is the one which we append to our internal memory or private memory. Now we give it as a memory. The next part, of course, is that to give a response to the user. Here, the response we can easily do like the self response engine, and we generate a response. From the generate response function, we can see also from here, we have a message, we add the message, and the NLP engine. The NLP engine, we initialize it inside the chatbot, so we use that engine. And this is as easy as it looks like. So we can easily change your response engine or whatever the components that you want to change, and easily, like a building block, build your own chatbot. Just as additional example, here we remove this part. These are the old codes that we had from previous example. We clean everything up and we call the recall memory, or we just call it recall, maybe that's easier. You can pause the video, just think about it, what can we do here? We want to use the memory class, of course, because the recall is from the recall memory. What we do, we said that let's do the memory, but as you may know, you cannot really use this memory here. You need to basically call the functions that we define here, recall memory. And based on the Dunder method, for example, we want to also check what kind of objects we are dealing with. We use the str1 in case that we use the print function, for example, to print our object. Then we return self name. To use this in our example, let's start to create all these components first. Then based on those components, we create our chatbot. The first one, of course, is the memory. In the memory, we can easily define it like this, because everything has been defined in the initialization function without any input. With the NLP engine, it's NLP engine like this. And with the response engine, of course, not the class. We can define the response engine like this. Okay, the bot is defined like this. Chatbot, we need to put the name. The name is, of course, we use the famous Aiden. The memory is the memory that we defined here above. The NLP engine is the NLP engine that we defined above, and also the response engine the same. And that's it. We create the object based on the components. Let's check with the print function how this object is behaving. The first one, we chat with the chatbot like hello. The second one, we want to give different message because we define an if condition for it, if you remember. So for example, how are you? And at the end, we want to check if everything has been saved inside the bots that we have, inside the bot's memory, basically. Let's also check how the class, let's check. Okay, here the print function, the first one, say that hi there, nice to meet you, because we send hello. The second one, since it didn't recognize it in our response components, here it needs to respond it back that you said, how are you? The memory in the recall saves all the message that I as a user sent to the chatbot, and the final print function basically shows that the chatbot is Aiden, as we define it in the Dunder method inside the chatbot class. And notice how neat and nice the design is. You can swap every component that you want in this design without thinking about other components. You want a smarter NLP engine, you can just easily define a new NLP engine, which is smarter, and for example, using ChatGPT. The response part and the memory part will remain the same. Or you want a different personality, like we had defined before in the previous videos. You can easily swap the response engine with different personalities that you want. And you don't need to write the whole chatbot to achieve that. So if you want to briefly connect this design to the best practice design in software engineering, we can define these principles which we already implemented here. The first one is single responsibility principle, or SRP, which means that each class should do only one thing. The second one is dry, or don't repeat yourself. For example, logic like greeting detection. It lives only in one place and not spread everywhere. And the last but not least, solid principle. This chatbot design is extensible and it opens to the new features without changing the existing class. This is how professional object-oriented programming design makes projects scalable. Let's see our chatbot again in action. For example, we want to add a new personality without touching the main class. Let's call it like friendly response engine. So here, in order to make it easier to understand, I copy-paste this engine and I call it friendly response engine. It generates the response, the same structure as generator response. The NLP engine is detecting the greeting, but we change the response to a friendly response. That, for example, hey friend, is very friendly, like that. Let's not make it so fancy. So happy to meet you. That's awesome. Tell me more about this. And awesome has a dictation problem, typo, and that should be okay. Now in the main chatbot, we don't need to change anything here. What we need to do, we need to define here the new friendly response engine. What we need to do here is just replace this part with the response engine, the default response engine that we had before. And when we replace it and run the code, you can see the response engine has been replaced. Now we have friendly chatbot, but the memory part, the NLP part, they're the same. And how we can do it without touching other part of the class, that makes the design scalable. Congratulations, you've just built a modular and extensible chatbot using advanced object-oriented programming in Python. That's it about this series. You have already learned a lot of things. You learned what are the classes, the attributes and methods, how encapsulation, inheritance, and polymorphism works, how can you use class methods, static methods, Dunder methods, and finally the composition and principle of clean design. With these learnings, you need to, of course, train and define your own projects and use these techniques in your own projects. So by that, it's your turn. Extend this chatbot, add the new components, even connect it to the API like ChatGPT to make it very smart. The sky is your limit, of course. Good luck, good morning, and good afternoon, and good evening. Bye.